Bismillah, alhamdulillah, salatu wassalamu ala rasulillah. Today, inshallah, we will study section 2.6. This section is one of the fundamental sections in this course. You will remember, I think, this course until you finish MATH002. You will use it in this chapter. Chapter 2 and also in chapter 3, in chapter 12. So wherever to function, formations of functions. It is not only about the graphs, it is about also the operations that you will have to apply for functions. What are the transformations that we have here, or the transitions that we have for functions? We have vertical shifting, horizontal shifting, and also reflecting in the x-axis and in the y-axis, vertical and horizontal stretching and shrinking, and finally we will mention the odd and even functions. Let's start with the vertical shifting. As it is clear from the name, vertical shifting, it means that you will move up or down. So the graph will be shifted up or down. So here, for simplicity, we will assume that C is greater than 0. So this means when we add a positive number, when we subtract a positive number. So that if this is your original graph, so if you have this graph, y equals f of x, if you add to the function plus c, so you are adding here to the whole graph c, then it will shift it up because c is positive. Of course, if it is negative, it will shift it down. And if you subtract a positive number from all the values of y, so all the y values will be reduced by that number, but that amount. So it will be shifted downward c units. Look at this. The blue one here is the original graph. When we add to the whole function a positive number c, then all the y values will be enlarged by c. Similarly, if you, of course, subtract a positive number or you add a negative number. For instance, x squared plus 3. This function, g of x equals to x squared plus 3. You should think about the original function. What is the basic function here?
X squared.
It is x squared, the squaring function. So here it is. What is the relationship between g and f? G, it is obtained from f just by adding. So we can say that g of x, it is just f of x plus 3. Now for the graph, what we will do? For the graph, this is the graph of y equal x squared. Now what we will do to sketch the graph of x squared plus 3?
You'll go up to 3.
So are we going to select some points and draw them, or what we will do?
3 steps upward.
So how to do that? How to make sure about that? In fact, you need to focus on what I can call it a key point. Always in each graph, there is a point. If you focus on that point, just hold it and move it up, and the graph will be moved up. Here, for example, here it is the vertex, this point. It was 0 and what? It was 0 and 0. Now it will become what? It will become 0 and 3. X will be unchanged because we are just moving up. So this point, it will be here. It will be 0 and 3. Now this will be the vertex, and the graph will be like this. So no need to think about more than that point. Just if you want to verify, you can just use it for verification if you want to add one or more points. For the another graph, x squared, for the graph of h of x, clearly that h of x here, it is just f of x minus 2. So it is the same as the graph of the function x squared, but shifted down. So the point that was here 3, here it will become now 0 and 0. Now it will become what? 0 and negative 2. So this is negative 2. Let's say this is negative 2. And the graph, of course, will be the same, but of course, it will be down. What is that? The domain here is all the real numbers. Of course, it will not be changed. And even if it is not, when you have a vertical shifting, the domain is still the same. The x values are not affected by this. What is affected here is the range. The range will be changed. For example, if you look at the range of the original function, it was from 0 to infinity. For this one, it is from 3 to infinity. For this one, it is from -2 to infinity. This is the graph in large scale. These are the three graphs. So you got it, what we should do to sketch or to apply the vertical shift. Let's now move to talk about the horizontal shift. And you need to connect it with this, by the way. Here, when we add a positive number to the whole function, let me go back here. To the whole function, we are adding a positive number or subtracting. When we add a positive number, we're shifting up. When we subtract, we're shifting down. Now, in the case of the horizontal, now it is about x, not about the whole function. So when we replace, this is our original function. When we replace x by x minus c, again, c is positive. Just if it is negative, it will be just here plus and here minus. It is the same. The same idea, of course, but not the same results. X minus c. So when we replace x by x minus c, we are shifting the graph what? To the right c units. And when we add or when we replace, let me think about it in a better way. It is not about adding and subtracting. It is about replacing. When we talk about x, we substitute x by x plus c. So when we replace x by x plus c, we are shifting the graph c units to the left. Look here, this is the original graph, the blue one. When we replace x, this x, when we replace it by x minus c, we are shifting the graph to the right because c here is positive. And of course, when we add x plus c, when we have x plus c, it is to the left. Let's apply it for this or these two functions. Again, our original function, even if it is mentioned here, you should think about your original function, which is x squared. So this one is obtained from x squared. How? Just x, it is replaced by what? By x plus 4. So this is what happened. Now, who can tell me what is the relationship between g and f? G of x equals what? In terms of f. It is f at x plus 4. It is the same, just evaluated at x plus 4. Go here, replace x by x plus 4. So it is x plus 4 all squared. So the graph of g obtained from the graph of f by what? By shifting to the right or left? To the left. Now, how to know that? Just this is the graph of y equal x squared. Now, if you want to know the graph of this one, again, you need to ask about this key point, where it will be. The vertex here, it will be where? It will be at -4 and 0. So it will be here. Y will be 0 here. Y will be 0 when x is -4. So the graph will be like this. This is the graph of y equal to x plus 4 all to the power. Similarly here, this is obtained h of x. It is indeed f of x minus 2. Just go back here and replace x by x minus 2. And it is in fact the graph of h obtained from the graph of f by what? Shifting the graph of f 2 units to the right. So the graph of this function will be here. It will be here at 2. The vertex will be at 2. I think we have them here in a better way. These are the three graphs, the graph of f and the graph of g and h. Okay. Now the third, let's combine now the horizontal and the vertical shift. When we have a combination of these two transformations, what we will do? Sketch the graph of this function. How to start when you want to sketch? Solve. What? Who says solve?
We need to sketch the origin. See the.
What is the basic graph that you will start with? Square root of x. So it is natural here to think about this graph, y equals square root of x. What is this graph? Here it is. You should know it. Before starting this section, ya shabab, you should know the basic graphs. The squaring function, cubing function, lines, square root, absolute value, and these basic functions that we have studied in section 2.2. If you know them, you can build on them and start creating other graphs from these basic graphs. So this is y equals square root of x. Then what we will do? We will shifting one by one. What we will do first? Shifting 3 units to the right. You are right. So now it will be, now the origin, the point again, the key point here, it is the origin, 0 and 0. Now it will be where? This point, which is 0 and 0, it will be where? It will be 3 and 0. Because now x will be changed because we have horizontal shift. So the same graph, the same shape, just move to the right. So this, the graph here that we have, it is for x minus 3. We should follow the same order of operations. So we start from inside, from inside to outside. X minus 3, then square root, then of course plus 4. Then the next step will be what? It will be shifted up. So the x will be as it is, 3, but it was 3 and 0. This point, it was 3 and 0. It will become now what? 3 and 4. So let's say this is 3 and 4. It will be here. And the graph is the same. So this is the graph of our function. You can verify, of course, if you are not sure about your graph, I advise you to verify. If you bought x equals to 3 here, what you will get? 4, right. If you bought, for example, x equals to, let's say x equals to make it easier, 4, what you will get? Is it reasonable? Is your graph is okay with that or not? Because you may have it or draw it in a wrong way. So you can use a verification point or more than even 1 point if you want to check. Excellent. The graph is here. The 3 graphs are sketched here. Again, focus on the key point. Now we have studied what? The vertical shifting, the horizontal shifting. Now we will talk about the reflecting. When we reflect a graph in or cross the x-axis or cross the y-axis. These are the main reflections, the main 2 reflections that we will mention in this course. So, and this should remind you about what we have done in chapter 1, at the beginning of chapter 1. Now, if you have, this is your original graph, y equals f of x. This is the function. Now, if you replace f of x by negative f of x, here it is. What will happen in this case? Then the graph of this function will be the same as the graph of this function, but reflected in what? In the x-axis. So it is similarly, just think about it easily like what? You are replacing y by negative y. So when you have y, when you are above the x-axis, let's say y is positive. When you are above the x-axis, if you replace y by negative y, you will be below the x-axis. So when y is negative and you multiply by negative, it will be positive, and vice versa. So in fact, you will have the reflection of the graph. If all the points here are reflected, then just imagine that you have a mirror here. You have a mirror here at the x-axis, and the graph here with red color, it is just the image of this blue graph on the mirror. So this is the reflection. Again, when we have all the function, all the y values, multiply by -1, so all the positive will be negative, all the negative will be positive. We will have a reflection in the x-axis. Now, if we replace x by negative x now, not y by negative y, if we replace x by negative x, what will happen? What is when x is positive, if we multiply by negative, it will be, if it was on the right of y-axis, it will be on the left of x-axis, and vice versa. Here we are. For example, if you have here x and f of x, this will be, of course, negative x and, of course, f of negative x, which is, of course, in this case, y is the same. It is unchanged. And we have, in that case, a reflection in the y-axis. This should remind you also about the symmetry. We mentioned similar things when we studied symmetry, symmetric about the x-axis, symmetric about the y-axis. Of course, if the graph is unchanged, it will be symmetric if you reflect it. Now, sketch the graph of negative x squared. Look how we will use the reflection here to sketch the graph of this function. What we will do? We will start with the basic function. Our basic function is what? X squared. So we will start sketching the graph of x squared. This is y equal x squared. Now to obtain the graph of this function, what we will do? We will replace the whole function by the x squared by negative x squared. So x squared, it was always above the x-axis. Now it will be always below the x-axis, but it will be reflected. Not only that. So this point, it is the same, of course. This point will be here. This point will be here. This point will be here. And you will have the reflection. The graph of y equal negative x squared will be the reflection of the graph of x squared in the x-axis. You can check. Don't move. You can verify that what you are saying is right or not by choosing some points like 1, 2, and check if it is correct or not. Excellent. What about if we replace? So if we replace, if we have another function, g of x equals to negative x all to the power 2. When we replace x by negative x, you can see clearly that this is the same as x squared. So the graph of this function is the same as the graph of what? Of y equal x squared. Why? We have a reflection. In fact, we reflected in the y. So what was here, it will become here, but it is the same. So the graph is symmetric. This is what I told you before in the previous slide. So when the graph is symmetric about the y-axis, you will not feel the reflection. The reflection, because you will obtain the same graph if you reflect it. And this type of functions, we will call them even functions. We will mention it at the end. When they are symmetric about the y-axis, it is even. When it is symmetric about the origin, it is odd. Let's take another one now. The next function is this. How to sketch the graph of this function? Y equal square root of negative x. We replaced x by negative x, so it will be reflected in the y-axis. So how it will be? Here it is. This is the graph of square root of x. Now, when it is reflected in the y-axis, it will be this one. Notice that the domain here is changed. The domain of the original one of this one, it was from 0 to infinity. But for this one, no, this is not. These are two functions indeed. It is not one function. And the domain of the function g, it is from negative infinity to where? To 0. Now, let me ask you about the graph of y equals negative square root of x. Where it will be? It is the same as this one, but reflected in what? In the x-axis. It will be here. So this is the graph of y equals negative square root of x. Now, what about the graph of the function y equals to negative square root of negative x? It is the same as the red one, but reflected in the x-axis. So this will be the graph of this function. Excellent. Now it is about vertical stretching and shrinking. Let's revise. Let's summarize now. We have studied the shifting up and down, right and left. So it is the vertical shifting and the horizontal shifting. Then the reflecting in the x-axis and the y-axis. Now we have the vertical stretching and shrinking. What is that? If you have, this is your original function. If you have a function and then the whole function, the whole y, has been multiplied by a number. Again, for simplicity, we will assume that this number is positive. If it is negative, you have a reflection. So if this number is greater than 1, then you have vertical stretching. So this means that the y values will be bigger. This is the meaning of stretching here. And if this number is less than 1, and of course greater than 0, then we will have shrinking, vertical shrinking. What is the amount of vertical shrinking or stretching? It depends on the factor C. Look here. We have here a blue. The original graph is the blue one, and the red is the one that has been stretched here vertically. When you multiply by C, when C is greater than 1. For example, here at the same x, look what was y. This is y. The point here, it is x and y. What is the point here? The point here, it is x and what? And cy. The function has been, the old y, I'm talking, this y is not the new one, it is the old one, multiplied by what? By c. Okay? Indeed, you can think about it like this. If the point x and y, it is on the graph of this function, then what will be the point on the graph of this function? It will be x and cy. What is this y? This is the old one, this y. Of course, if it is less than between 0 and 1, it is like dividing. So it will be shorter, it will be shrunk. It will be smaller. For example, if it is here, for example, 1 and this is 2, here it will be 1 and 1, for instance. So the y values will be smaller when we have vertical shrinking. Let's take this example. 3x squared. How to sketch the graph of this function? It is you will start with x squared, then you will do what? Vertically. It will be vertically stretched. How it looks like? What do you think? Is it going to be narrower or wider? So this is x squared. Let's say this is x squared. Is it going to be like this or like this? Let's see. So in fact here, this is the purple here is the graph of x squared. This one is x squared, y equal x squared. Now this one is y equals to 3x squared. What happened? Of course, at 0 it is 0. Look here, when x is 1, when x, for example, when x is 1, what is y? It is 1. Here it is. Now look at this graph. When x is 1, what will happen? It will be 3. So look, here it is. This is when x is 1. So in fact, because it is a parabola, it looks like it is now narrower, not wider. But of course, it has been stretched vertically up. It has been stretched up. The values of y becomes greater, bigger, what was before. Look at this one. What do you expect will happen? It will be vertically shrunk. It has vertical shrinking by a factor of what? By a factor of 3, third. It will be minimized. The values of y will be smaller. For example, at 1, it will become what? Third. Look, here it is. It looks like it becomes wider. In fact, here, as I will show you later, the horizontal, when we have horizontal shrinking and horizontal stretching, in fact, this graph is wider now. So it is horizontally what? Stretched. And the red one, it is horizontally shrunk. It will be the opposite in that case for this function, especially for x squared. Now, yes.
How we can draw like this?
Which one? You can select some values, but of course, you can just look at the factor, the function x squared multiplied by a number less than 1. So the values of y will be smaller. You will start with the purple one, then all the values of y should be less than, so that it will be below the graph of x squared. This one, it is above because the y values are greater.
But I mean, like I have to exact.
If you want to, you need to choose some points to make it exactly. But it is so easy. You have y equal x squared. You need to sketch the graph of, for example, 4x squared. What you will do? You will draw here y equal x squared. Because 4 here is greater than 1, so it will have vertical stretching. It will be like this. Let's see, you can do this here. Here we have a combination of shifting, stretching, and reflecting. Please try to sketch the graph of this function. Try to sketch the graph of this function. 1 minus 2 times x minus 3 all to the power 2. It will summarize all what we did so far. I'll take the attendance. Let's resume. What is the basic function, Abdulaziz, that we will start with here? Think about what is the original function here, Shabab. We have squaring function here. So what we will start? We will start with y equals to what? This is what you should start with, not with x minus 3. So this is x squared. What happens now? You know how to sketch this function. It is we sketch the graph several times. Now, what is the second function that we will sketch? X minus 3 all to the power. We should follow the same order of operations, starting from the inside to outside. the order of operations, parentheses, powers, multiplication, division, and addition and subtraction. You remember it from chapter B. Now, the graph of this one, Abdulaziz Sayrafi, will be where? It will be shifted the same as the graph, but shifted to the right. So it will be here at 3. So the graph will be like this. Okay. Now let's go and sketch the graph of what now? We will multiply by 2. You can do it at once, by the way. You can multiply by -2 and reflect and stretch. But let's do it one by one, no problem. So here we are. What will happen to this graph? And I'd like to draw them at the same place because it will be easy for you to compare between them. Let me draw here. The blue one will be 2 multiplied by x minus 3 all to the power 2. What will happen? It will be like this, right? It will be narrower. The y values will be bigger. The y values now will be bigger. Abdulaziz Hossa, it is clear now for you how it will be. Now let's do in this step, let's do the reflection together. So here we will do the reflection. What it will be? It is also a 3, but it will be reflected in the x-axis, not in the y-axis. Here we are. The graph will be like this. The last step that we need. Sorry, what is what?
Why in x-axis?
The function, the whole function multiplied by negative. The whole function has been multiplied by negative. We didn't replace x by negative x. We replaced the whole function by negative the function. Now, what else now? What is the last step? We have adding 1. So we will add to this function. We will add 1. Of course, you can write it on the right or on the left. The addition is commutative. Now, what we will have in this case? This point, which is 3 and 0, it will become what? It will become 3 and 1. Here it is, and the graph is the same. You can use, of course, some checkpoint. You can find the x-intercept, but no need. We are just sketching the graph just to focus on the reflections. Let's look at them again, Shabab. The graph here, the black one is x squared, the purple is x minus 3 all to the power 2. Now the blue one is negative 2x minus 3, and the final one is this.
The last thing, if we subtract from the odd function,
Shifting up and down, it is vertical stretching. We will summarize that at the end. I'd like to mention here this remark. Note that the shifts and stretch follow the normal order of operations when evaluating the function. The final transformations that we have are the horizontal stretching and the horizontal shrinking. These two transformations, in fact, they will be used in 002. We don't have here many examples about them. But when you study the graphs of sine and cosine in MATH002, you will use these two transformations heavily there. What they are? You remember the example that I show you? I'll go back to it, but let me here mention how it becomes the horizontal shrinking and the stretching. If we have a graph of a function y equals f of x, if we replace x by cx, here it is. Again, for simplicity, c is positive. If it is negative, we have reflection in the y-axis. If c is greater than 1, we will have horizontal shrinking. What is the amount of this horizontal shrinking? 1 over what? 1 over c. And the amount of horizontal shrinking, stretching, if it is between 0 and 1, also it will be by the factor 1 over c. Look here, when c is greater than 1, when we replace x by cx, but c is greater than 1. The original graph is the blue and the new one is the red one. What happens? Horizontally, it has been what? Shrunk. The x values becomes what? Smaller. And here, the x values are bigger. Because when you, of course, when you have c greater than 1, Shabab, 1 over c will be what? Less than 1. So this is why the amount here of the factor of shrinking or stretching, it is here greater than 1. And it will be less than 1 in that case. In a simple way, because the factor is 1 over c and the factor is 1 over c, it becomes, it wasn't like that before, Shabab. In the vertical, it was, this one was c, and this one it was c. Simply to think about it like this, if the point x and y, it was on the old original graph, what it will becomes in the new graph? It will becomes x over c and y, because the amount or the factor of stretching or shrinking, it is 1 over c, not c like the case of vertical. Let's look at this example. This graph is for y equals f of x, the original function. Now, how the graph of this function will be? Sketch the graph of this function. Y equals f of 2 of x. What will happen? What is the amount of shrinking? What is the factor of shrinking? Every point will be shrunk by what? By half. So the point 1, it will becomes where? Here. And let's take an example to make it much easier. Let's take 1 and what? We have here 1 and what? And 0. Now this is in the old graph. What it will be in the new graph? It will becomes 1 over 2 and what? And 0. So the graph will be here. So we will have this. Okay, right? We will see. Now, for example, if you take another point, a half, at a half we have here what? 1. What this point will be under the same graph? It will becomes 1, a half over what? Over 2, which will be what? 1 over 4 and 0 and 1. So at fourth it will be 1. Here it will be 0. At fourth it will be 1. At fourth it will be 1, and the graph will be like this. We have it here. I think it is better to look at it here. So everything, ya Shabab, will be shrunk. Again, you will study and understand this more in MATH002 when you study the graph of sine and cosine. We don't use it too much here. Just you need to focus on the factor of shrinking. Look at this now. What will happen here? See here, it is a half. So it is less than 1, greater than 0. So we will have here what? Horizontal stretching. Now the point, let's take a point, for example. Let's take a half, the same point that we took before. A half and 1. What it will be, and under the effect of this function, y equals to a half of x. So it will be a half divided by a half and 1. It will become 1 and 1. So this point that was at a half and 1, this point, it will becomes where? It will becomes at 1 and 1. Look, here it is. So the x values has been enlarged. The x values are bigger. At the same y values, at the same one here. At 1 it was a half. Here at 1 it was a half. Now at 1 it is 4. Here at 1 it was a half. At 1 it is 1 now. So every x has been multiplied by the reciprocal of the c of the factor. The last part of this section is about even and odd functions. Let me go back. I promised you to show you the effect. Look here. In fact, here you can see that we have here, for example, in this case, we have horizontal what? Horizontal stretching. Look, this is what we are talking about. A third here is less than 1. In fact, you are just replacing x. You have y equals to x squared. This one, how it is obtained from here, Shabab? By horizontally. Think about it horizontally. In fact, here you are replacing x by what? By 1 over square root of 3 all squared. Is that right? This is the same as this. So this is the c that I'm talking about. It is 1 over 3. It is less than 1. So we have horizontal. Here, how this obtained horizontally? This is in fact square root of 3x all to the power 2. So we have here horizontal shrinking, and this is what is happening. Horizontally, it has been shrunk. And of course, don't generalize. We are not saying here that if we have horizontal stretching, it will be vertically shrunk. No, this is just for x squared for this specific graph. It might be for others, but not in general. like this, for example. You can say the same. Now let's go back to even and odd. And this also should go back to the symmetry. You should remember what we have done in chapter 1. When we say that the function is even or the function is odd, you know about the odd and the even numbers. So what about the even and odd functions? The function f is even if the value of the function at negative x is the same as the value of the function at x. What is that? For all x in the domain. This says if you replace x by negative x, the function will stay unchanged.
That means the function is negative.
If it is negative, it will stay negative. If it is positive, it will stay positive. The value of the function at negative x, it is the same as the value of the function at x. It doesn't matter if you change x by negative x or the negative x by x. In fact, when we talk about reflection, what is that? When we replace x by negative x, we have reflection in what? In the y-axis. So this means that if you reflect the graph on the y-axis, you will have the same graph. It will be unchanged. And the graph of even functions, this is why the graph of even function is symmetric with respect to what? To the y-axis. Do you remember how you studied the symmetry about the y-axis in chapter 1? You replace x by, if you have the same graph, the same equation, it is symmetric about the y-axis. So if the graph is symmetric about the y-axis, then the function is what? Even. And if the function is even, it is symmetric about the y-axis. What is the best example about that? X squared. Look at x squared. X squared, if you replace x by negative x, you will have the same x squared again. You have the same function. If you reflect on the y-axis, in the y-axis, here, this point will be here, this point will be here, you will have the image, the reflection of this part is the same as the reflection of this part in the y-axis. This is your mirror is here. And you can see clearly that the name is coming from here, by the way. The polynomials with one term, let's talk about power function. When you have a power function like this, if n is even, it will be even function. If it is odd, it will be odd. But it is not, of course, for any polynomial. We will see that. Let's go back now to the definition of the odd function. If you replace x by negative x, and you didn't obtain the original function, you obtained the original function, but multiplied by what? By negative. This means that all the signs has been changed. In this case, the function is what? Odd. It is symmetric about the origin. Yes. Why it will be symmetric about the origin? Do you remember from chapter 1 when the function is symmetric about the origin? If you replace x by negative x and y by negative y, and you have the same function. Look here, we replace x by negative x and y, the value of the function, it becomes the same as the value of the function, but multiplied by what? By negative. So here we have negative x and negative y. So here we are. This is the origin of Shabab. If you have the line here, like a mirror, the mirror is here. The graph of this part here, it is just the reflection of this part. The graph of odd functions are symmetric with respect to the origin. If you have a graph that is symmetric with respect to the origin, then it is for odd function. What about graphs that are symmetric about the x-axis? If you have a graph that is symmetric about the x-axis, it is not all odd or even.
I think it's not a function.
Abdurrahman, you're right. It is not a function. So what you are talking, we are saying odd and even functions. So if it is symmetric about the x-axis like this, the part here is the same as the part here. So this is not a function by the vertical line test. If it is symmetric about the x-axis, so there is no function symmetric about what? About the x-axis. Okay, and now what about if we replace? So what is the criteria? How to test? If you have a function, how to test it for it is even or odd? What you will do? You will replace x by negative. If you obtain f, the same function, then it is even. If you obtain this, it is what? Odd. What about if you didn't obtain this or that? We will call it neither. It is neither even nor odd.
So this is the other way. Can we check its function or function?
No, it is not another way. Now look here, x to the power 3. If you replace x by negative x, you will get the same function but multiplied by what? By negative. So f at negative x, it is the negative of the function at f. Let's see, determine whether these functions are even, odd, or neither, each one of them. The first one, what do you think? How to show me, how to convince me that it is odd or even? What you will do? You will work on f at negative x, and you will see if you get the same function at the end, then it is even. If you get the negative of the function, then it is what? Odd. If you get something that is not the function, not the negative of the function, then it is what? Neither. It is neither. That's it. So what do you think for the first one? F of negative x will be negative x all to the power 5 plus negative x. What we did, we replace every x by negative x. Simplify. Is it the same as the original function? So is it the negative?
Yes.
How to know? Not multiply. Multiply what? Take negative 1 as a common factor. Now this is negative what? What is this? The original function. Negative f of x. So f of negative x is equals to negative f of x.
And also true if we multiply by negative.
Multiply what? Multiply what? When you multiply, you should multiply both sides. What is that? Are you solving equation here?
Okay, if you multiply both sides,
You did nothing. If you have f of negative x equals to negative x squared plus x, if you multiply both sides, what you will do? This is what you will get. It is not about multiplying here. Be careful, Shabab. When you multiply one side by a number, you are changing the value of the function. It is just about taking negative as a common factor, negative 1 as a common factor. Just to see, of course, it should be clear for you from here, but this will make you more sure about that it is the negative of the function. Look at G now.
even.
Replace x by negative x. Now this is negative 1 to the power 4. It will be 1 minus x squared, which is the same as the original function. So this function is what? Even. The last one?
No.
It is neither, because if you replace x by negative x, what you will get? You will get negative 2x minus, this negative will be positive, so it will be minus x squared. Is it the same as the original function? It is not. So for sure it is not even. Now let's see if it is odd. What we can do to check that if it is odd? Take negative as a common. What you will have? 2x plus x squared. Is this function is the original one? No, it is not. The original one is 2x minus x squared. So this function is not the function, and not the negative of the function. It is h, by the way, not f. This is not h of x. This is not h, negative h of x. So this function is it is not even. It is neither even nor odd. That's it, ya shabab. This is section 2.6. The summary is here. This slide, especially this slide, you will remember it for the whole semester, and maybe also for the whole year, because next semester you need this slide. In this slide, you have the shifting up and down, right and left, reflecting in the x-axis, the y-axis, stretching vertically and horizontally, shrinking vertically and horizontally, and of course, the even and odd functions. Let's practice by solving some exercises. Unfortunately, we don't have much time, but look at this interesting exercises. How to sketch the graph of absolute values. Look, if you know how to sketch the graph of y equals f of x, you can draw this one easily. How? The idea is to use the definition of what? Of the absolute value. So this will become what, ya shabab? It will become f of x or negative f of x. This is what is the absolute value of x, of x is. It will be f of x if what? If what? X? No, we are not talking about the absolute value of X. We are talking about the absolute value of F. This if f of X is greater than or equal 0, it is f of X less than 0. What does that mean? If the function is greater than 1, by the way, this means what? What is f of X? F of X is y. This means y greater than 0. And this means y less than 0. The y is the same as the function here. Now, if y is greater than 0, which means when we are above the x-axis, keep the function as it is. When you are below the x-axis, multiplied by what? By negative, which means reflected in the x-axis. Here we are. This is the graph of x squared minus 4. You know, it is x squared shifted down 4 units. Now look how the graph of the absolute value of x squared minus 4, what happened? What was above the x-axis, ya shabab? Here f of x is greater than 0, greater than 0, greater than 0. It becomes like as it is. Here it is. What was below the x-axis? Here we have f of x less than 0. We reflected, we multiply by negative. So it has been reflected in the x-axis and it becomes like that. In 1 minute, sketch the graph of this one. How to sketch the graph of the absolute value? If this graph, you will see how to sketch the graph of this one in chapter 3, by the way. Don't worry. This graph, it is here. How to sketch the graph of the absolute value? What it will be? Again, the same idea. What is above the x-axis will stay above the x-axis. What is below will be what? Will be reflected. So it will becomes like this at -4. So it will become like this one. Here we are. The blue one now, it is the graph of this one. It's a graph here. That's it for today. We will practice tomorrow, inshallah, by solving the recitation exercises. Thank you and see you tomorrow.